Welcome. At this point, we're pretty good at solving quadratic equations by factoring, and today we're going to kick that up a notch and take it to the next level and talk about solving quadratics by completing the square. Now, part of this process is to simplify radicals, so I want to take a minute or two before we get started solving equations and review simplifying radicals. I'm in your purple packet on page 36. And I'm going to go ahead and jump down to number 5. We'll look at one of these and only one of these together because most of you are pretty good at this by now. To simplify radicals, what I'm going to do is I'm going to look at everything under the radical, and I'm going to separate all of the terms under the radical into factors that are perfect squares and factors that are not perfect squares. So for number 5 here, that coefficient of 2 out in the front is just going to cruise on down to the next line. He's not underneath the radical, so I'm not going to do anything with him. And then I'm going to set up two different radicals. And again, the first is going to be factors that are perfect squares, and the second factors that are not. So when I look at what I see underneath the radical symbol, I've got 144. 144 is a perfect square, so I'm going to put it under my perfect square radical. Now, if that were a number like, say, 18, I would split the 18 apart into 9 times 2, and the 9 would go under the first radical. The 2, the non-perfect square factor, would go under the second radical. But back to this example. Looking at the h to the second power, that is a perfect square. He's going to go under the blue radical sign. J to the first power is not a perfect square, and he'll go under the second radical. And that k to the third, he's not a perfect square, but here's the catch. He has a factor that is. I can take out of that k to the third a k squared, of which I can take a square root. So I'm going to put k squared under my first radical, which leaves me with a k remaining under the second. And now if I were to think about going backwards and I were to multiply everything under the blue radical times everything under the red radical, I would end up with exactly what I started with, that 144 h to the second power, j to the first power, k to the third power. All right, moving to the next line, 2 is going to stay 2, but at this point, by the way I designed this, I have underneath my first radical all terms that I can take square roots of. So square root of 144 is 12, square root of h to the second is h, and the square root of k to the second is k. Also by design, I have underneath that second radical all factors that I cannot take square roots of. And so they're simply going to stay or remain under that radical exactly as they are. To finish this up, I'm going to multiply my factors of 2 and 12. And as a result, my answer ends up being 24 times h times k times the square root of jk. But the big idea here is that under the first radical go factors that are perfect squares, and then we in turn take their square root. Under the second radical go factors that are not perfect squares, and because they're not perfect squares, we do not take their square root. All right, so that was a little bit of good review on simplifying radicals from last year. Now I want to really jump into the good stuff, and I want to talk about solving quadratics by completing the square. So notice that the directions say to solve each equation by completing the square. I'm going to zip ahead now to page 39. And on page 39, I'm going to scroll all the way down to the bottom of the page. So remember that our directions said to solve by completing the square. Factoring is a great strategy, and it works wonderfully sometimes. Completing the square is a great strategy to use when factoring doesn't work, or really any time you want to solve a quadratic equation. So my first step in solving this equation is going to be to move all of the terms that have the variable, so in this case p, to one side of my equation and all of the terms without the variable to the other side. And since this is set up with some p terms on the left and it already has that constant of -3 on the right, I'm going to go ahead and start off by adding 29 to both sides. So when I add 29 to both sides, that leaves me with p squared plus 4p on the left and positive 29 plus a -3 or 26 on the right. And this is the stage at which I'm actually going to complete the square. And I'm going to complete the square by adding the same constant to both sides of my equation. So I'm going to take the two terms that I have on the left side, the p squared plus the 4p, and I'm going to add some mystery term to the left side. And then I'm going to go ahead and add that same mystery number to the right side. Remember that I can add or subtract whatever I want as long as I do the same thing to both sides of the equation. Now you might remember from last year that the way that we're going to get this mystery number, oh, my little gremlins are inside my computer again, is by taking half of that coefficient of that number in front of p and squaring it. And I'm going to write that down because that's a step that kids sometimes forget. So half of 4 is 2. 2 squared is 9. I lied. 2 squared is 4. And that's the number that I'm going to go ahead and add to both sides. I'm now going to factor the left side. And the left side of my equation will factor into p plus 2 times p plus 2. And I'm going to combine the terms that I have on the right side to get 30. And it just so happens that the factors on the left side will always be a perfect square. So in other words, I can rewrite this to say p plus 2 quantity squared. And that's by design. When you completed the square and added that 4 to both sides up in the third line, that actually created this scenario or created this situation where when we factored, we would end up with two factors that were exactly the same. I'm now going to go ahead and I'm going to take the square root of both sides, remembering that when I take the square root of the right side, I have to take both a positive and a negative square root. So that gets me to p plus 2 equals positive or negative 30. And then to solve for p, I'm simply going to subtract 2 from both sides. And that'll get me to my final answer, which is -2 plus or minus the square root of 30. So what that tells me is that one of my answers here is the -2 plus the square root of 30. And the other of my answers is that -2 subtract the square root of 30. So that way that I boxed in red and the way that I just boxed in yellow, those are two different ways of saying the exact same answer. If I needed to, I would have, of course, simplified that square root of 30, but 30 isn't a perfect square, nor does it have any factors that are. And that kind of made my job easy in this situation. All right. The second example that I want to take a look at with you is also on page 39. And the directions for this also say solve by completing the square. So again, I'm going to go ahead and I'm going to start this out by putting all of the terms with the variable on the left side, all of the terms with the constant on the right side. So I end up with m squared plus 2m equals, when I add 92 to both sides, that gets me to 99. And it's important to note here that the coefficient in front of the m squared is a 1. If that were a number other than 1, like 2 or 3 or 7 or anything other than 1, We would have to divide every term in the equation to make that leading coefficient of 1. We're not going to take a look at any like that this year, but you'll see some like that next year in your Algebra 2 class. All right, so my next step is to go ahead and to do that step where I complete the square. So again, I'm going to look at that coefficient of the m term. I'm going to take half of it and square it. And that is the mystery number that I'm going to add to both sides. So half of 2 is 1. And when I square 1, I get 1. 1 is the number that gets added to both sides. So I'm going to go ahead and factor the left side. And when I do that, it becomes m plus 1 times m plus 1. And again, that will always be the same number multiplied together when you factor it. If it's not, that's a big clue that you made a mistake somewhere along the line. And then equals that sum of 99 and 1, which is 100. I'm going to rewrite the left side to make it m plus 1 quantity squared. And then proceed by taking the square root of both sides. Remembering that when I take the square root of that 100 on the right-hand side, I have to take both a positive and a negative square root. And this one is a little interesting because that 100 is a perfect square, so when I take its square root, I end up with 10. So now subtracting 1 from both sides of my equation leaves me with m equals negative 1 plus or minus 10. And I would not leave that as such in this case because it's not simplified. So remember that this really means m equals negative 1 plus 10 or m equals negative 1 subtract 10, meaning that my value of m can either be 9 or negative 11. So those are a couple nice examples to look at. I know that some of you remember this from last year because I've seen some really nice completing the square solutions from you earlier in the year when we did quadratics. But if it wasn't so fresh in your memory or you didn't remember quite as well, now you've got a nice little refresher so that you can go ahead and you can solve these equations by completing the square. For those of my students who are here in the classroom today, it's very lucky for you that you have Mr. Correa here. He's wonderful with completing the square, so if you have questions, please don't be shy about asking Mr. Correa. I know that he will be more than happy to help you. For those of you who are watching this video at home, please bring any questions with you when I see you in person tomorrow, and of course I'll be happy to help with anything that you need help with when I see you in class in person tomorrow. All right, so folks, you've got your calendar, you know what your practice problems are, you know what your homework is. I haven't taken up too much of your time, so you should have a nice little chunk of it to get grinding away on those practice problems that are due tomorrow. All right, take care, stay cool, bye for now.